Thank you for watching videos of mekanizmalar channel. There are infinite numbers of coupler curves you can generate by using this animation. Please click here to go and play with this interesting program to generate interesting coupler curves and enjoy it. Many mechanisms can be broken down into equivalent 4-bar systems. The 4-bar linkages are considered to be one of the fundamental mechanisms. In a 4-bar mechanism, the red linkage of the rotating members usually is the driver and is called the crank or driver. The other, the green linkage, usually is called the rocker or follower. The floating blue linkage that connects the crank and the rocker is called the connecting rod, and the fixed black linkage is called the frame. In this animation we are going to investigate the coupler curves generated by a special 4-bar linkage. In this linkage, the length of the crank and rocker, as well as the length of the blue and black linkages are equal. Also, the follower is always at the opposite side of the crank with respect to black linkage. In this case the middle point of the blue linkage generates an infinity sign-shaped coupler curve. The characters A, B, C and D represent joint points of the linkages. The location of the character E can be changed as percentage of CD by using one of the input boxes shown here. Note that 50% represents the middle point, while smaller number brings E closer to C, while the larger number takes E closer to D. You may also use negative percentages. The character F represents the location of drawing point. As you can see, it is initially set to 0. In this case E and F overlap. Any positive or negative number takes F away from CD line such that F is perpendicular to the CD linkage. You can see the lengths of CE and F by checking the corresponding checkbox shown here. Also you may make the characters invisible, if you like. Notice that the crank, the red linkage, rotates uniformly, while the follower, the green linkage, rotation is not uniform. If dashed plotting lines are spaced and longer, then the follower rotates faster than the crank. On the other hand, if the lines are closer, then the follower is rotating slower than the crank. We can show this by first making CE distance equal to 0. As you see, the curve becomes a circle around A and it moves with a uniform speed. Now let's make CE equal to CD, then curve becomes a circle around the B, but rotation is not uniform as the line segment's length is changing. Now let's change again to the initial configuration. Since AC is the half of CD, the curve is passing through A and B points. However, we can change that by changing either the AC or CD length. Now the coupler curves will not pass from A and B points. Let's take E closer to A. As you can see, we obtained a raindrop-shaped coupler curve. We can also get similar symmetrical shape by taking E closer to D. We can also make E away from A in negative direction, and this arrangement produces a different shaped coupler curve. And finally, by taking F away from E, we may get very interesting curves. Thank you for visiting our channel and watching our videos. We encourage you to subscribe to our channel and rate our videos. Your support is important to us.